What's up, guys? Hey, welcome back from spring break. I know that things are a little weird with the announcement that we're not going to be back in the building this year. We're just going to try to make the best of it. We're going to try to make it honestly as easy as possible for you guys. Keep it from being stressful, and yeah, just trying to make it all good. So this week, what we're going to be doing is we're just going to be reviewing everything that we've done so far with Quadratics. Okay, so um, it's I'm just going to assign a review. You're going to work on it a little bit every single day. It's around 18 problems, so you knock out 6 problems a day. Have that thing done by Thursday, and yeah, you'll be good to go. So with that being said, I'm just going to run through each little section on the review. So the review goes part A, part B, part C, and I'm going to give you an example of each type of problem. So this video might be kind of long when it's all said and done, but just skip around. If you're good on part A through D and you need help on part E, skip to part E, right? Just whatever you need. Also, my wife and I were on a walk, and we decided to shave my head. We got a little bored, so yeah, that's what's going on with this haircut. So anyway, let's go ahead and get started. Part A. So think back to before we were solving, we were factoring, right? That's when we were taking an expression and we're splitting it up into two pieces, pieces that are multiplied together to create it, right? And what we started with was factoring out a GCF. So if you're looking here, we got to factor out the biggest term that can divide all of these things evenly, right? So start with the coefficients, 7 and 42, 7 and negative 42. What's the biggest number that divides both of those evenly? Well, that number is actually 7, right? And then k to the fifth and k to the third. This has 5k's, this has 3k's. What is the most of the most amount of k's that they both can give? 3 of them, right? K to the third. So this is our GCF. This is what we're factoring out. Now we got to figure out what's left. Well, we factored out a 7 and 3 of those k's, so we're left with 1k squared, right? Factored out 3k's, we have 2k's left. And then negative 42 divided by 7, that's negative 6. K cubed, well, we took all 3 of those k's away, so there's none left, right? And remember, you can always check your work by multiplying back in, making sure you get what you started with. 7k cubed times k squared, 7k to the fifth. 7k cubed minus 6, negative 42k cubed. So that's factoring GCF. All right, part B was that special case that we kind of learned, honestly, right when we were starting all of this online learning. And it was called difference of squares, right? And it looks exactly how it sounds. A difference, a subtraction of two perfect squares, right? X squared and 4, those are perfect squares. Minus means difference, right? And remember, this factored into a binomial times a binomial, right? And you take the square root of each one of those terms. So the square root of x squared is x. The square root of 4 is 2. And you take one of your binomials and add them. The other one, you subtract them, right? And that's how you factor a difference of squares. The square root of the first term plus the square root of the second term. And then the same thing, but subtraction, right? So if you're looking at this example, again, we got two perfect squares. 16x squared, that's a perfect square. 81, that's a perfect square. Again, it's going to factor into two binomials. The square root of 16 is 4. The square root of x squared is x. So the square root of that first term is 4x. The square root of 81 is 9. And again, one of these is added, one of those is subtracted. So once you got the pattern down, those are super easy, right? Hopefully you remember that, but if not, now you do. Part C, factoring trinomials. So again, this was before we learned anything about solving. We're just factoring. Once you split it up, you're done. Okay? So factoring a perfect square trinomial, right, in standard form, ax squared bx c, where a is 1. Remember, this is where this factored into x and a number times x and a number. We just got to figure out what those two numbers are, right? And the way we figure that out is we figure out what two numbers multiply to negative 50 and add to positive 5. And those numbers are negative 5 and positive 10, right? So that factors into x minus 5, x plus 10, and we stop here, right? We're not solving this. We don't see an equals 0 or anything like that. We factored it out. We stop there. Because if you were to multiply this binomial times this binomial, you would get x squared plus 5x minus 50. That's what it means to factor, to split it up into its two pieces, where if they were multiplied, you get back where you started. So that's part C. Part D, factoring trinomials where a doesn't equal 1. And I've got two examples here because there's kind of two different ways you're going to see this. In this case, both of these are ax squared, bx, and c, but a is not 1. So it's not going to factor into x and x, right? It's going to factor a little bit differently. And we've got to figure out how that's going to look. So the first example that you might see where a doesn't equal 1 is a case where you can factor a out, right? Think about it. The GCF, if we're thinking about a GCF here, you always want to think about GCF when you're factoring. First, 2, 16, 18. 2 is actually the GCF of the coefficients, right? Factor out a 2 first. That means we divided 2 out of every term. That means we have 1x squared. Negative 16 divided by 2 is negative 8x. Negative 18 divided by 2 is negative 9. And now look what we have inside. Inside of here, we have a perfect square trinomial. A quadratic trinomial where a is 1, right? Now, keep that 2 on the outside, and you know the inside is going to factor into x and a number times x and a number, right? And again, this is where we're going to have to see what are those two numbers that multiply to negative 9 and add to negative 8. And those numbers are negative 9 and positive 1. X minus 9, x plus 1. And this is our final answer, right? You see how we were able to factor that 2 out to make a be 1, and then we could factor it like normal? So sometimes, if you're kind of thinking about the way this is going, sometimes you won't be able to factor out that a. Look down here. Can you factor out a 6 from this? No. 11 and 10, those aren't divisible by 6. So this was a little different. With these, remember the first step we did to factor ones like this was we multiplied a and c to get negative 60, right? Let me make that blue. Negative 60. Up top here, that's a times c. And y'all remember what we put down below? Still b, just like always, right? Put down b down below. So what are the two numbers that multiply to negative 60 and add to 11? This one can be kind of tough. So you just take your calculator out, mess around with it. You should get positive 15 and negative 4, right? So from here, what do we do with those numbers? Well, we take 15 and negative 4 and we split up this plus 11x into those two numbers. I've got 6x squared plus 15x minus 4x minus 10. You see how I took this middle term plus 11x and I split it up into plus 15x minus 4x right here? Because what's 15 minus 4? It's 11. So these are equivalent, right? And we got those numbers from here. Now what we do is we factor by grouping. So group together the first two terms, group together the second two terms, and factor out a GCF from each one of these groupings. Remember, this one was a little bit longer. There's only one of these on the review, so but it is something good to know. So what's the GCF of the first pairing, right? To factor by grouping, now we're going to factor out this GCF. Well, between 6 and 15, it's 3. And x squared and x, I can take out an x, right? That means I'm left with, on the inside, 6 divided by 3 is 2. X squared, you took out 1x, you got 1x left. 15 divided by 3 is 5. You took out an x, you don't have an x left, right? In other words, you're trying to verify that if you multiplied 3x into all of this, would you get what you started with? And you would, right? So now this next one, remember, whenever that first term is negative, you're going to factor out the negative with it. So minus 4, actually in this case, not minus 4, minus 2, right? Because the GCF between 4 and 10 is 2. And I'm left with 2x plus 5 again when I factor that GCF out, right? And if you guys are remembering, this is a really important point. These have to be the same, 2x plus 5, 2x plus 5. If those aren't the same, then that's a good sign that maybe you messed up somewhere. But if these are the same, then you know that you're almost done. Your last step, take the ones that are the same, 2x plus 5, 2x plus 5, bring that out front. Now, what's left over if you factored out the 2x plus 5? 3x and minus 2. That's your second factor. So this one's a little bit longer, but these are the case where you've got a standard form quadratic where a doesn't equal 1 and you can't factor it out, right? So there's that one. All right, part E. We just spent that entire time factoring only, but we never solved. Solving is where you have an equal sign and you're trying to determine what does x equal to make the equation true, right? We never had an equal sign with any of the problems we just worked out. Now we do. So this one says solving by factoring. So we're going to use the skill we just did to help us now solve, right? But the first thing we have to do to solve by factoring, it has to be equal to 0. Is this equal to 0? Definitely not. It's equal to 16. So how do we make this equal to 0? Well, our first step is to subtract 16 from both sides, right? To make this 16 0, you got to subtract 16. But you have to do it to both sides to keep it equivalent, right? So I've got x squared. Is there any like term on the left side with a 16? No, right? This is an x squared. This one's got an x. So you're just going to write the minus 16 at the end. And all that is equal to 0. Now we're ready to factor and solve. So it says solve by factoring. So how do we factor this guy? Well, we just did it, right? It's a quadratic trinomial where a is 1. So I know I just got to figure out the two numbers that multiply to negative 16 and add to negative 6. And those numbers are minus 8 and plus 2, right? So we factored it. Now our final step is to split up our factors into two separate equations, because what we now know is if this factor times this factor equals 0, if you multiply two things together and they equal 0, then either one of the factors equals 0 or the other factor equals 0. And hopefully you remember that from when we learned this the first time. So now go ahead and solve both of your equations, because once you split them up, you've got two really simple one-step equations, don't you? I have x equals 8. Over here, I got to subtract 2 from both sides. And x equals negative 2. So we didn't just factor, but we used factoring in order to solve. So hopefully you remember how to do that. I'm going through these a little bit quicker because it is a review. If you're struggling with these, go back and watch the earlier videos where I talked about them more in depth. Hop on a tutoring session that's going to happen at different points this week. Be on the lookout for announcements about that. And yeah, so we got 2 more examples to go. Solving by square root. The kind of the key to look for when you're solving by square root is the fact that we don't have an x term. We have x squared and we have constants. That's a good sign you're going to be solving by square root. So solving by square root, you're going to solve this kind of like you would a normal equation that we were doing at the beginning of the year, a linear equation. You're just going to try to get x by itself. So the first thing I'm going to do to get x by itself, I'm going to subtract 11 from both sides. I'm left with 2x squared equals 50, right? Now, I've got to divide both sides by 2. I'm trying to get rid of that coefficient on the x squared. And I'm left with x squared equals 25. And I think y'all are seeing where this is going, right? So what's the last thing keeping x from being by itself? It's that squared, right? How do I get rid of that? I square root, just like the method's called. So the square root of x squared is x. And think about this. This is what's kind of new for us. The square root of 25, in this case, it can be positive or negative 5, right? 5 squared is 25, negative 5 squared is 25. So you've got to include both the positive and the negative. Don't forget that in your answer. I got good news. We're on to the last example, part G, quadratic formula. I'm not going to lie, the emails were pouring in. You guys were telling me how much you love quadratic formula. I heard words like fun, amazing, fantastic, exciting. And I'll be honest, I'm super happy to hear that. So I'm glad that the quadratic formula has been able to fill your quarantine with a lot of fun. So that's awesome. Hey, to do quadratic formula, right, you got to make sure it's quadratic. It is x squared. And just like with factoring, it has to equal what? Right, it has to equal 0. Does it equal 0? Heck no, it equals 15. How do we make it equal 0? We subtract 15, don't we, from both sides. And just like before, I don't see any like terms, right? I don't see another constant over here. So I'm just going to be left with 8x squared plus 14x minus 15 equals 0. Y'all see that? Now I've got my quadratic equal to 0, and I can start filling out this guy's quadratic formula, right? So let's do that. X equals, a little dust on the screen there. Draw myself my fraction bar, and let's just fill out what we know. So first of all, it says minus b. That just means take the opposite sign of b. If b is positive, it's now going to be negative. So negative 14 plus or minus the square root of, right? Y'all see how I'm just filling it out piece by piece. B squared, that's 14 squared. Remember to put that one in parentheses every time, just in case it's negative, right? You want to make sure your calculator knows what you're talking about. Minus 4 times a, which is 8, times c, which is negative 15, all over 2 times a. Again, I filled that one out kind of quick. If you're struggling with quadratic formula, go back to my original quadratic formula video. Give it a like while you're at it. Hit subscribe. Just kidding. But for real, go back to that video and I go through it a little bit more in depth. But that's the setup, right? Just A, B, C, fill out each piece where it goes. And the best part about this is just plug it straight in your calculator, right? So I've actually already done that. So when you plug in, one thing that can confuse people is what do you do with this plus and minus? Again, that's 2 different operations. So the first time you're going to plus, the second time you're going to minus. With the plus, I get 3/4. So I'm going to go back here. And one of my answers is x equals 3/4. And I got to go back and do the minus to find my second answer, right? And the best way to go back is just to scroll up, highlight the formula, and scroll over to that plus sign up here and make it a minus, right? We did the plus. Now we're doing the minus part. And you get negative 5 halves. So negative 5 over 2. So that's quadratic formula, right? Take your pieces, make sure it equals 0. Take all your A, B, and C, plug it in where they go. Throw all that mess in the calculator, and it does all the heavy lifting for you, right? So that's part A through G, right? That's every part of the review. I'm going to post these notes as well. That way you can look at my work. Just break it up piece by piece. Give it your best shot. And seriously, email me, text me, Canvas message me, jump on one of those tutoring sessions. Come say what's up. And yeah, we'll make sure that you're straight and ready to go. So have an amazing week and keep in touch. And yeah, good luck.